In this video, we're going to look at the components of a vector. Now, the components of any vector are the smaller vectors that we can split up a vector into. So, for example, in this triangle here, we can see that this vector along here, r, is actually equal to a plus b. So r equals a plus b. Now we've already seen that r is called the resultant of a and b. So r is the resultant of a and b. But we can also go the other way and say that a and b, they are the components of r. So the resultant r is made up of the components a and b. But a and b are not the only components that make up r. We could have other vectors. Maybe we have a vector c and a vector d, like that. C and d would also be components of r. Maybe we have another one that comes here and here. Vectors E and F. They are also components of R. So we need a way to come up with a unique way of splitting up any vector. And the way we do that is we have to use perpendicular vectors. And the perpendicular vectors we use are ones in the x direction and in the y direction. And these are called the unit coordinate vectors. And any vector can be split into a unique pair of coordinate vectors. So for this vector here, we can split it into the horizontal and the vertical. We have a horizontal vector and a vertical vector. And these are called I and j. So I is in the x direction. So if we have the x direction, I is the unit vector, a vector of length 1 in the x direction. And j is the unit vector in the y direction. So for example here, we might go across, maybe this is 8, so this would be 8i, and maybe it goes up 3, so it's 3j. So in this example, a, our vector a, is equal to 8i plus 3j. Splitting it into the component vectors I and j. Now, the length of A, the magnitude of A, is easy to calculate here, because the magnitude of A is just equal to, well, we can use Pythagoras' theorem because we've got a right angled triangle, because we chose I and j to be perpendicular, so we just get the square root of 8 squared plus 3 squared, which is equal to the square root of 64 plus 9, so the square root of 73. So let's have a look at an example of a question where I and j are being used. Here we're given 3 vectors, a, b and c, and we're asked to find the coordinates of A. Now notice here that this vector is a position vector as well. It's telling us where A is from O. So another way we can write this is OA is equal to minus 2I plus 3j, because these are all position vectors. So the coordinates of A are nice and easy because it's a position vector. we've just gone 2 to the left and 3 up, so the coordinates are -2, 3. In part B, we're asked to find the vector AB. That question should, of course, have an arrow across the top there. Let's add that in. So B, we're trying to find the vector AB, and to do that, we can use what we saw in a previous lesson. AB is equal to, well, it's the position vector OB minus the position vector OA, which is equal to, well, OB is I minus 2j, and from that we're going to take away OA, which is minus 2I plus 3j. And now we can do the arithmetic here, do the algebra. Get I minus 2I is 3I, and minus 2j minus 3j is minus 5j. So the vector AB is 3I minus 5j. For C, we're asked to find the position vector of D, given that ABCD is a parallelogram. Now, if ABCD is a parallelogram, we know that AB is equal to CD. But we also know that AD is equal to BC. We've got these two pairs in our parallelogram. If we imagine we've got a parallelogram, we've got A, B, C, D, and AB is equal to, oh no, it's not equal to, CD is equal to DC, so we just need to correct that there. It's equal to DC, and AD is equal to BC. That one is right. Okay. There's a very good point here. Make sure you visualize it correctly. Use diagrams to help you so you don't make mistakes like that. But we know, well, we want the position of D, and we're going to use this information here. So we have, let's use this one over here. AD is equal to BC. So we can find BC. BC is equal to OC minus OB, which is equal to 3I plus 4j when we work it out. And BC is equal to AD, so this is also AD. And we know that the position vector, well, if this is AD, that's this bit here. So if we've got some O down here somewhere, we want to find the position vector OD, but OD is OA plus AD. So that's the last step now, is to find OD is equal to OA plus AD, which is equal to minus 2I plus 3j, because that is just the vector A that we had at the beginning, plus AD, or AD we just worked out was 3I plus 4j. So that gives us an answer that the position vector of D is equal to I, and then 3j plus 4j plus 7j. So that's our final answer for the position vector of D. So that's how we can split a vector up into components.